Hello, welcome to lesson 5 of this Introduction to Coding series. I am your host, Megadeth. Today we're going to be talking about a pretty broad subject, and I'm going to be fitting as much information as possible in it without sort of going over the boundaries of what you haven't learnt yet, which I'll get into in a little bit what I mean by that. So we're going to be talking about functions, and it is one topic and one topic only, but man, is it a good one. Functions is what makes code reusable, much more readable, and just all around what a computer program actually is. To describe a function is pretty much how you describe it in real life. A function, it's a function of the program. It's one part of the program that does a specific thing. Just like a function of your car is to drive, to go, to stop, to turn it on, turn it off, turn on your lights, turn on your wipers, turn on your radio, etc. You get the idea. So we're going to talk about functions, and in depth we're going to go into how the program actually flows when you use functions. We're going to write functions, declaring versus defining functions, much like we did with variables. We're going to discuss calling functions and how to actually use what you've written, variables for functions, which might do your head in a little bit, but I hope not, and returns, which we have seen before. If we go into our previous program, we have our little return 0. So we will get into that now. Now I've just started a new project, which I will set as startup before I forget. And I will copy this bit of data here so it doesn't kick us out of the program at the end. Once again, this is your base program. Just write this if you want to follow along. Don't be too concerned with what this is. It'll actually make a lot more sense after this lesson, and even more sense again after the next lesson. Actually, by then it should make perfect sense. So I've got 3 game cartridges and 2 Xbox One games, which are going to act as props for part of what I'm doing because I am very bad at preparing things. But let's talk about functions. So generally speaking, when you write code, you try to split things up into sort of logical pieces, and that's what your functions are. In the case of my game engine, okay, let's just bring up my game. Let's bring up a new window with my game engine because I can't be bothered flicking between the projects. It's much easier to flick between windows, and I'll just put that up a little bit. Cool. Let's open it up. Oh no, you could see where my code is stored. It's on my C drive. Oh no. All right. So let's talk about, say, my base item. Now, I'm not going to explain the difference between a H and a CPP file just yet. But here's a list of my functions. I have this special function here called a constructor, which I will go into at a very later date. Don't worry about that one. And we have functions like get my stats, get my stat modifiers, get my base value, get my modified value, add a stat, add a modifier, set name, set description, get name, get description, set size, get size, so on and so forth. It's a little abstract at that point, so let's go to something a little bit more concrete. We have a vector. Now a vector in math is an x-dimensional, I don't know if it's the right word, it has x amount of values, and in math, in 3D math, you use 3 or 4, depending on what you're doing, x, y, z, and then u if you're doing rotations, but I'm not, because I'm not that smart. It's been too long since I did it, so don't ask me to understand it too much at the moment. All I remember is gimbal lock, something like that, where the planes collapse and you can't twist things. Anyway, so some functions here, I got plus, minus, divide, times, and a couple of other divide and times, a couple of comparisons, compare, and a clone. And then these other operations that are part of vectors, dot product, cross product, angle between, length, and normalize. Do not ask me to tell you what they do. I just do not remember for the life of me. I actually wrote all this. I don't remember how it works. It's a common theme with most programmers, unfortunately, especially ones that work with things like math that you don't use very often, where you just write it once, get it working, and you just forget about it. I cannot tell you off the top of my head how you initialize DirectX and make a game screen come up. It's just beyond me, but I've done it. I've like 100 times. Anyway, so what kind of program are we going to write today? We're going to do something extremely simple. We're just going to do something that outputs stuff to the screen because that's all we know how to do. We're going to do some simple addition and multiplication. And I don't know, we'll get a bit funky a bit later on. So let's talk about how a program actually works. And well, actually, let's just write a function first, eh? So there is a couple of ways you can actually write a function, and I'm going to get into both of those at the moment. So remember back at lesson 4 here, we have our initialization and our assignment, and then we have our initialization and our assignment. Functions are much the same. So the syntax for starting up a function initialization is the return type, so that the data this function will give back, the name, then parentheses, they will always be there. The parentheses is what actually determines that it is actually a function rather than a variable. And inside the parentheses, you can have data that's being given to the function. And then the curly braces to signify the body of the function. So let's do something simple. Now, let's say we are going to do, what's simple? Let's do additions, okay? Let's do an addition. We're going to get two numbers, and we're going to return the addition of those numbers. So we're going to use integers. It's just going to be very simple. So the return type for adding two integers is going to be an integer. So int. Now, very important to note, in C++, you can only return one value. There are ways around it, but for the most part, it's one value or zero values. In C#, in some other languages, you can get around that, but it's honestly never really that relevant. So int, we're going to call our function addition, or let's call it add these numbers. We're going to do our open parentheses and do our curly brackets at the moment, and then we're going to go into actually how we give it values. Now, once again, much like over here, we need to give it some values to do the addition on. And it's done exactly like this. We just are initializing a variable. So int first and int second, separated by a comma. You can put in as many arguments as you like. These are called arguments when they're in a function. They're, the variables that go into a function are called arguments. Now, in the case of C++, I don't believe there's an actual upper limit of how many variables you can have, but I'm not going to bother trying. The only real restrictions you have are naming, so it's the same as writing any other piece of code. They can't start with numbers, they have to be unique. I don't think I mentioned that actually. Variables have to be unique, because otherwise they get confused. And once again, you can have anywhere between 0 and anything. So if you wanted 0 variables, simple, it's empty, you have 0. I want 2 variables or 2 arguments, so I put 2 in. Whatever they are called here is how they will appear in this function, and that will make a little bit more sense in a second. So let's do some addition. Thankfully, math in C++ and basically every programming language there is exactly how you would write. If you were doing algebra and you had a variable called first and a variable called second, you would just do first plus second. Now, if we recall back to the return keyword is how you give data back to the function. So in this case, we're going to return first plus second. Now, this function is extremely unrealistic. You would never write this. This is a waste. If you wanted to add 2 numbers, you would just literally add 2 numbers. But it's the least complicated thing we can do that has all of the elements we need to learn a function. So let's just roll with it, okay? Now, I'm going to do something funky here, which I've already done, which you haven't noticed, because I'm just that good. And we're just going to continue. Now, we have written a function, and it is over there somewhere. So how do we actually call it? Well, much like retrieving data from a variable, you just use the name. So what we want to do is we want to create 3 integers. The first number we want to add, the second number we want to add, and the number that we want to get back. So let's just do that now. So int first, I'm going to call it something else. Int number 1 is going to be equal to 10. Int number 2 equal to 20, and int added numbers is going to be equal to, well, it's not going to be equal to anything at the moment, so let's leave it empty. Now, how do we call a function? So to call a function, as I said, you just type the name, add these numbers, you do your open parentheses, and you'll see your lovely IntelliSense telling you it needs a first and a second number. Now, in more complex functions, if I go back to my engine, let's find something that makes a bit more sense. So we have a rectangle here. Okay, so a rectangle, and you're giving it the position of the left, the right, the bottom, and the top. It's pretty descriptive. First and second, not so descriptive, but it's pretty simplistic. You get a lot of context clues. Add these numbers, and you're given a first and a second number. You can probably work out what it's doing. So how do we give it these values? Well, we want to actually recall them values. So the same as you do it here to print it out on the screen, you just use the name again. So we've got number 1, and we want to give it a second value, so it's a comma, and number 2. And of course, the semicolon at the end. And you'll notice that this and this is pretty identical. And that's by design. It's all the same kind of syntax. Now, how do we make this result, which is first plus second, return into added numbers? Once again, much like assigning a value, you just do your thing, added numbers, is equal to that. Now, at a very basic level, the way this works is this does the function. So it'll go, okay, you're giving me number 1, number 2, so 10, 20 here, 10, 20. I'm going to add them and I'm going to return it back. So that this whole block here will be replaced by the value, which is 30. It's an extremely simplistic way of looking at it, but that is pretty much how it works. And I'll show you with my game cartridges how it works in a second. Now, this is not actually going to compile. And you will see this error here, identifier not found. And we saw this a little bit in the last one. It's like, oh, well, that means that the thing isn't named properly. So what the hell's going on here? Programming is top to bottom. The very top of the page to the very bottom of the page. Much like if you read a book and you started at page 100, say Harry Potter, and it's got, oh, this is Hagrid. Who the fuck's Hagrid? Hagrid said this. Well, he was introduced on page 50. I don't know who he is. This is the same kind of thing. We're trying to add these numbers, but anywhere before that, we don't actually know what it is. So how do we do that? Well, let's just rearrange it. And now we're going to build it. And it's going to go, sweet, cool. So let's also output this to screen. So C out again, added numbers, and end line, and let's start it up. You see, we have 30 on the screen. Simple, very simple. So let's actually see how it works. So this is where my handy dandy game cartridges come in, okay? So when the game comes in, when the program starts, there is a thing called the stack. Now, the stack is useful for a whole lot of things, but the name stack should give you a mental image of how it actually works. A stack is literally a stack of things on top of each other. Sorry about that, I made a mistake and I have to erase it and start again. So, when you start a program, you have a thing called the stack. Now, the stack, the name should give you a visual interpretation of what a stack actually is. A stack is literally a stack. It is one of the many data structures that you use in programming. Now, the stack is what's known as a first in, last out data structure. So think about it as a stack, right? So we have one thing, we put something on top. Actually, let's do it that way so you can actually see the labels, and put something on top. Now, unless you're playing Jenga, when you take something off a stack, it comes off the top. So the first one you've put in down the bottom here is the last one that's going to come off the stack. Now, the alternative to that is a first in, first out structure, which is something like a queue, and literally just this is like a queue at the bank. First person into the queue is the first person out of the queue. First in, first out. They each have different uses, they each have different advantages and disadvantages, and they each have different use cases. In the case of a program, you want to stack because of the way it works. Now let's explain. So you come into the program and we are settled here at int main. That is where the program entry point is, and this is something we talked a little bit about. So right now, this Wall Defender game cartridge is main. This is your int main function. We're going to read down the code here, and we're going to get to add these numbers. This is a different function. Now, you can see very visually here that this is not the next line of code. It's actually 10 lines before it. So to do this jump, what we need to do is we need to put a reference on the stack to say, we are now somewhere else. This here, Wall Defender, that's where we were before. We need to go back there. We need to return there, hence the keyword. But now we're up here. And once again, top-down programming. We're going to start at the top, and we're going to execute our code from the top. So it's going to go return first plus second. Okay, cool. So this Great Escape cartridge here is now worth 30 in the case of this program. And it's going to give that data back to the guy underneath it, and it's going to go, okay, sweet, I have 30 in my hand, let's shove it where it needs to go. Continue down to the bottom. We're going to hit return again. This thing's going to come off the stack. We have nothing left. The program's over. That is a very simplistic but hopefully very visual way to explain how a program actually works. And once you get your head around the way functions work, you can do some really cool stuff and really dig down into how you can make really complex programs. Excuse me, have some Coke. So let's go back through our example here. Now, this is a pretty inefficient and very simplistic way of doing things. We don't really need number 1 and number 2 to have variables. We could replace this with 10 and 20, like that. That's fine, that will also work. They're still integers, they're still the same piece of the data. It will still work fine. But we're also storing it and just displaying it on screen. So let's cut out the middleman. Let's just display that result directly on the screen. And now we can remove this and start it up, and we'll get the same result. But what we've done is actually cut down a lot on the time that's happening in the background. It's not nothing that you and me will ever notice, but if you were to attach a timer or a profiler, you would actually see pretty significant jumps. Pretty significant being very, 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 very small amounts of time, but potato, potato. So we have now written a function. We are now fully fledged programmers. We have written a function, we have called it, we have brought data back. We're amazing. So what other cool things can we do with functions? Well, before we go too far ahead, let's talk a little bit about the difference between defining and declaring a function. So if you right click this guy, you'll actually get both definition and declaration. And it's going to be a bit hard to see here. So let's jump over to wherever the freaking hell I have some stuff here. So let's go to definition. So the definition of a function is the actual meat of the function. It's actually where the data happens, where the magic happens. And the declaration of the function is where you actually say, hey, somewhere there's a function, and this is what it is. This is the signature. So what do I mean by that? So remember before we had this down the bottom, and our program didn't compile because it didn't actually know what it was. And if you recall back to what we had lesson 2, we talked about compilation steps, and we talked about the linker. This is where that comes in. So let's just say, for argument's sake, I want this down the bottom for neatness. Or I have 2 functions that each sort of need each other, and I can't really have one above the other. They need a way so they both know that each other exist. Excuse me. The way we do that is the same way back here that we sort of declare the data separately and then assign it separately. We do something very similar. The way we do that to do a function definition, hang on, if I got the right word. No, a function declaration. Oh man, they're too close together, mate. They upset me. Is the exact same with a slight difference. Instead of putting in your curly braces, you do a semicolon. This is saying somewhere in this code there is a function called add these numbers. It takes an integer, it takes 2 integers, and returns an integer. And now if we go to build this code, this will actually work. Because this guy here, he knows that something like this exists. And when it comes to the linker, and the hint is in the name, it'll actually link this to down here. Much like clicking an anchor in HTML, you know, you click a link in Wikipedia, it takes you down the page. Exact same kind of concept. And this kind of thing is very much more common when you get into big programs like this. So I have all my declarations, my definitions, or no, all my declarations in one file and all my definitions in another. And it's a very convenient way to split things up. And that is something I will go into in a lot more depth a bit later on. You don't really need to know about it now, but that is why we do this kind of thing. And also, you know, ordering and neatness and all that kind of stuff is also really good, but not really as important. Okay, so let's talk about other types of functions. So I mentioned before about returning 0 pieces of data. So let's just say we want to print something out to the screen. So let's write a function. What's our return? Well, we're not returning anything, so let's leave it blank. The name is print out to screen, and we're going to take a string called the poop, and we're going to end it. What's the error here? Function definition for print out screen not found. Huh. Okay, why is that? Well, if you have a look, this here is extremely similar to this. The only real difference between a definition or declaration and a call is you remove the return type, but we're not returning anything. So what do we do here? Well, C++ and its infinite wisdom has a return type that means you return nothing, and that is called void. Now, void itself can actually be data, but let's pretend it's not, because to be honest, if you're using void as data, I personally think you've done something wrong. No offense. But I do see its use, don't worry, I do see its use. So we've created a function that returns void, which is technically nothing, and it takes a string. So you're probably asking yourself, well, if I want to have 0 inputs, do I use void? You can, but you could also do print, do some work in background, and just leave it empty. Void will work, I believe, unless they changed that recently. I have used that, I think, in C, maybe not in C++, but it's unnecessary. You just leave it blank, and it kind of shows off what you want it to do. Now, these are underlined green because we need to do the definition, which is this guy down here. So how do we do it? If you're smart, you'll copy and paste, but you can obviously just type it out. It's literally the same thing without the semicolon, and we stick in the curly brackets. That is the difference between a declaration and a definition. So how are we going to print this out the screen? Okay, so we're going to do just like normal, standard, cout. What's our data? Our data is poop. Of course it is. And then we're going to end line. Very simple. And now, let's do exactly what we just did. Print out to screen. And what's the data? Well, we want to print out the result of this. We're not storing anywhere, but we can call a function. Like that. Now this is actually erroring out because this needs to be an integer, because I'm silly and I wanted to prove a point. So there we go. We've changed it over to taking an integer from a string because this is an integer. Now that actually errored out because C++ is what's known as strongly typed. You can't have real interchange between two variables. Let me qualify that in a second. And the variable you tell it, you have to tell it what variable you're expecting, what type. You can't just go, it's a variable. Something will come in and you'll figure it out. A lot of languages do allow that. I personally don't like it because it lets you do funky shit, and I don't like funky shit when it comes to programming. I expect it to work exactly how I expect it to work every time. Now, the caveat from before is you can convert it into a string, you can convert a string to an int, and you can convert backwards and forwards between a lot of different types, but they're all manual processes. It's not automatic for the most part. You can set it up to be automatic, but that's you manually having to do something. Because you have a bitmap and a PNG, they can be converted between each other, but the computer doesn't know how to do it. You have to tell it how to do it. That's something we'll actually go into, I think, next lesson. But we'll leave that for now. So let's actually do... No, it's okay. Cool. So let's see what happens here when we run this. It prints out 30 twice because we got it there twice. Now, you might look at this and say, well, this plus this is a lot more than this, plus that as well. And you'd be right. But let me show you why you use functions, even for simple tasks like this, okay? So let's say I want to print out, I'm going to add these numbers. I'm not going to change the values. The values don't matter. Okay? And we'll comment this piece of code out so it doesn't actually do anything. And let's run it. Cool, we have 36 times. And let's make it a little bit more dramatic. Let's do it however many times that is. It's like 15 times. Okay, so we have it coming out to the screen 50 times. I'm your boss. I'm going to come up to you now and say, hey, that 30 or those numbers you're putting out to the screen, I actually wanted to say 30 units. And you're like, fuck, I have to change this thing 15 fucking times, or 20 times as it may be. But if from the start you were a thief and you stole my heart, and I had this as this instead, oops. Okay, you'll see that it prints out the exact same thing, 30, 20 something times. But now when I want to go add the units, I'm going to go, okay. Oops, I did it the wrong way. I've now just changed that once. And I have 30 units 20, 30 times on the screen. The beauty of functions is if you're doing a task repetitively, and all of a sudden that repetitive task needs to change slightly, if it's self-contained in a function over there, it's going to change everywhere when you change that one place. So let's say you're a baker, and I'm telling you that you have 5 different loaves of bread, and the only difference is I give you a different type of wheat to do it with, or a different type of flour, or something like that. If I have to give you a single bag plus that extra bit of flour, and all of a sudden one item in that bag changes, I just change what's going in the bag. You'll still get the same bag, you'll still throw it into a blender or a mixer or whatever else and put it in the oven for the same amount of time. That's cool. But if I give you 10 different items, or even all 10 of them change, I all of a sudden have to rework everything. I have to rework the recipe. I have to tell you what the things are, where they go, and when they go. And it doesn't make as much sense. I know it's a really bad analogy. It's really hard to try to think of one. But any kind of task that is done the same with maybe 1 or 2 things differently, you could probably stick that into a function. In the case of adding numbers, the only thing that changes are the numbers that you add. Now, once again, it's not a very good example, but it's a function. If I all of a sudden wanted to change this, add these numbers to be first plus second plus first now, I've done it. And all 30 places are going to change. That's now 40, because 10, 20 plus 10 is 40. If I want to change the way they're printed out to the screen, I don't have to change each one individually. I just sort of change it here. 40 is going to be poop units. And just to make it interesting, I'm going to change that one to 49 because I am a child. There we go. Oops, I forgot how to math. It's 118 poop units. Because I don't like being beaten by a computer. Much better, 69 poop units. And that's all changed everywhere. Some examples like this are how you, say in a game engine, you render something into the screen. You don't want to be writing that every time because it's always going to be the same. But if I all of a sudden come up with a different method of rendering something to the screen, I don't want to change it in 1,000 places. You change it in one place and everywhere else calls into that. So now let's talk about the stack again and how this will work. So this is a pretty interesting case because you have a function within a function, or a function within a function. So let's get our trusty game cartridges back out again. So we're already in main. And so it's going to go print output to screen. Bonk. What are our inputs? Our inputs are add these numbers, which is a function. So now we have 3 stacks deep. It's going to execute add these numbers. It's going to pass the data back. It's going to execute print to screen. It's going to pass back nothing. It's going to pop off the stack again. And we're back at main. And then we're going to go back to print out the screen, add these numbers, and so on and so forth. When I started programming the stack and things you can do with functions like recursion and calling a function from a function from a function from a function really did my head in, because it wasn't really clearly explained in such a visual way, which is why I hope this actually helps a lot. And that actually reminds me, I should write that down. We should do recursion at some point. Recursion and other funky shit. So that's my lesson plan I'm typing into, so I don't forget. Now, what haven't I... All right, cool. So the last piece of data, the last thing we're going to actually talk about is how data gets transferred between places, basically. So let's get rid of all of this. Let's add to these numbers. Let's basically go back to the start. So number 1, 10, oops. 2 is 20, int addition is nothing. Add these numbers, number 1. This is back to where we were at the start. If this doesn't make sense, please let me know, or go back and read over what we just did. Look at, whatever. And we're going to use our nifty print to screen function to print out our addition. And we're going to get rid of poop units because I will try not to be a child for a bit. So let's say we do some funky stuff here. Let's go first is equal to first plus second, and return first plus second. So what this is going to do is it's going to be first plus second basically. So it's going to go a first is equal to first plus second, so it'll be in this case 10 plus 20, so first is equal to 30. Then first plus second, which is 30 plus 20, it'll return 50. Now, that part is simple. I'm just going to leave this piece of code commented out for now, but I want you to sort of think about what I'm trying to do here. That's 50. We have edited this piece of data that's been given to us. So you'd think to yourself, well, why do I need a return value? I've gotten a value and I can just give a value back. There are a lot of reasons why you will want to do that. Okay, cool. So let's run it. So let's print out our addition and then print out our first number again. Our first number is 10, but I changed it. So what's going on here? So let's talk about it. There are 3 ways that data can be passed between functions. Now, there are 2 ways I'm just not going to talk about yet because that's very much more advanced. But the way we're doing it is called pass by value. This is the same as me going, I have 2 numbers in my head, number 1 and number 2. And I'm going to go to you, hey, can you add 10 and 20? And then you go, okay, the answer's 30. But in my mind, I changed 10 to be 15 for some reason. Okay, cool. My number 1 and my number 2 up here hasn't really changed. I've just given you 2 values. That's literally what's happened here. This value is literally being copied into this first, and this value here has been copied into this second. But there's no link back. These numbers aren't staying in sync. They're gone once the function finishes. They don't exist anymore. The data's gone. First, it could be equal to 1 billion. But this number 1 isn't going to change. And something I actually should have mentioned a little bit more clearly, this number 1 and this first, they don't have to be named the same thing. The way these variables work is just the order. If I was to switch these 2 around, it wouldn't make a difference because they were just adding 2 numbers. But if I was to do this, first is now going to be 20, and second is now going to be 10, which I have to talk about something else at some point. Let's write that down. Cool. So it doesn't really make much of a difference in this case, but let's say in this case, int poop and then int p, because once again, I am 3 years old. Can you catch up? Thank you. Let's output a space in between and then the number p. Good Lord. And I forgot to change my declarations. Let's do that. These two must stay in sync. Otherwise, they don't know what each other are. If I tell you to link two things together and I change what one of them are, you're not going to know what's going on. And now you'll see these are erroring out. So let's just go number 1, number 2, and then number 2. Oops. Thank you. Number 1. And you'll see it's 1020 and then 2010. The order in which you give the values to it are the order in which it will get the values. So once again, if I tell you to print out two things to screen 10 and then 20, or if I tell you to print two things out to screen 20 and then 10, you're going to do that differently. If I tell you to write on the wall the number 10 and then the number 20, then the number 20 and number 10, it's going to be different. So once again, computers work very much, or at least C++ works very much like you would. At least like I would, if you're a weirdo, so cool. So once again, these values are actually copied over to here. There's no link back. You can't modify the data. When I talk about things in the future, you can. You can actually sort of dick around with this data, because doing this can be quite inefficient, because literally, as I said, you're making a copy. For an integer, it's 4 bytes. It's nothing. A computer can do that in an instant. But if I need to pass around, say, a 50 meg bitmap, you're not going to be wanting to make copies of that. Like, could you imagine if the Photoshop filters you use, every filter passed this big massive chunk of memory to each other? It might actually do that. It's horribly inefficient. So what you do is you create a reference or a pointer, which maybe you can determine what they are just by saying them, and you work off those. But that has the downside of you're able to actually modify data. So if you have a shitty programmer on your team, he could ruin your data and everything goes to shit. Happens more often than you'd think. But yeah, that is pretty much all I think I had for functions. That actually went by pretty quick. 40 minutes, cool. The main takeaway, best practices. Best practices. I always forget about best practices. So let me talk very, very quickly about best practices. This poo and p is fucking stupid. This should be left item or, first thing to print or something, right? Something descriptive. If I write a function that says it's called blah and it takes an integer of poop and then a string of blah and then a float of p, and I tried to code that, I would lose my fucking mind if someone else did that to me, and you should if you're doing it to yourself. It makes no sense. Everything should be descriptive that you write. Variable names, function names. When you work into more things down the line, everything should make sense. In context and out of context. Once you learn what a string makes sense in context and out of context. Number 1, number 2, they make sense. Add these numbers, that makes sense. Print out to screen, that makes sense. You know what that's doing just by looking at it. You don't have to go print out the screen. Or what does print out the screen does? Oh, okay, print something out to screen. You don't have to actually read into the code. If you went into my game engine and you go, what's something that's good to look at? My state, maybe. This item here. I have an item. I'm going to set the name. I'm going to add a stat, and I'm going to add a modifier, and I'm going to set the equipment slot, which is the right arm. I'm guessing you understand what that's just done in terms of data, or in the terms of a function. It makes sense just at a glance. If I have a sprite and I set the position, you know what that's going to do. And these values here are called X, Y, and Z. You know what that is. That's the X, Y, and Z planes. They all make sense. At a glance, you know what is happening, and it is so important when you're reading hundreds and hundreds of lines of code at a time to try to figure out what's going on. Or even if you're writing code, it makes sense because you don't have to go switch between where it's defined and actually read through the code to see what it's doing. You know, because you shouldn't care, you know, how this print out to screen function works. That doesn't matter to you. All that matters to you is you have something that you can plug into that prints something out to the screen. That's all that matters. That is the principle of good programming, good functions, is you make it readable, you make it simple, so that the next person that comes along knows what's happening straight away. There's an old saying, and I don't remember the entire thing, so I'm probably going to screw it up. Write code like the guy who maintains it is unstable and knows where you live. Keep that in mind. As for other best practices, I tend to use functions as upper camel case. A lot of other programmers do as well. I think it's a de facto standard, but it's up to you how you do it. You can do underscores, you can do whatever you want. I don't think there's much else. Oh, one big thing that I've mentioned in one of my rants about Yandere simulator, you want to keep functions as small as possible, around 100 lines. Now that might sound very large, but you can write functions that are 600 or 700, 1,000, 5,000 lines. So what you need to do is break it up into logical sections. So you have one big overarching function, 10 or so smaller functions, which have 10 or so smaller functions, something like that. But the goal is to definitely keep it as small and as brisk as possible. It's obviously not always the case. You're doing a lot of complicated shit. It needs to get bigger. Break it up so that it's easy to read, easy to understand, and most importantly, easy to maintain. Because you're the one who's probably going to be maintaining it and making changes. So make it easy on yourself and think ahead. That is going to be it for this one. I really hope, that you understand functions. Physical things like some game cartridges, some DVDs, anything like that, even just some pieces of paper. I've used pieces of paper to teach this stuff before. Really help understand the stack. Get out a piece of paper, write a program like this that has functions, calling functions, and just visualize it on a physical stack of shit. It doesn't matter what it is. If you want to take the keycaps off your keyboard and use that, fantastic, as long as you can visualize what's going on. Otherwise, I will see you next time for basically what is an extension of this lesson, which I incorrectly mentioned in the part 2 of last lesson as going to be something else, but we're going to be doing operators. And I really enjoy operators. They're really cool and they're a really interesting piece of programming, and we will see you then. Goodbye.